higher powers of I. So we're going to do that on the back in a second. But on the front, we're mostly going to focus on division and some tools we might need to simplify complex fractions. So grab a pen here. All right. So at the very top, I just wrote this definition so you guys could see it. It says number pairs of the form A plus BI and A minus BI are what we call complex conjugates. Okay, literally the only difference between the two, one has a plus and one has a minus. They just switch up the sign in between. That's all a conjugate does. There's also irrational conjugates. We'll get into that more second semester, but when we have complex numbers with the I in them, they're called a complex conjugate. Let me just give you, I'm just going to make up an example. So let's say I had, I don't know, 4 plus 3i. Literally all you have to do to write the conjugate is just change up that symbol in the middle. So its conjugate would be 4 minus 3i conjugates. So conjugate literally just means you change up the sign from a plus to a minus or a minus to plus, depending on what you're given first. So if I want to write the conjugate, now this just has an imaginary part. So the conjugate here would literally just be change this to plus 12i. The conjugate for this guy, if you start with a minus, you're just going to switch that up to being a plus. I'm just changing the sign in between the two numbers. And then this last one I put on here on purpose. So you don't make opposites of everything. So if this starts with a -6, when you write the conjugate, that will still be -6. It just changes the sign in the middle, not anything else, just the sign in between the real part and the imaginary part. Okay, now the reason I'm showing this to you is we're going to use this in a couple problems today, but just for some practice. This says multiply the conjugates from part A, so the one we just did. So if I take -12i, and I multiply that by its conjugate, which is positive 12i. You can always multiply. So -12 times 12 is -144, right? I times I is I squared. Does anyone remember what I squared is equal to? -1. Okay, so really, this is -144 times -1. So this is positive 144. Okay, and I'm going to do the same thing. So that's a conjugate with just a single imaginary part there. And just to remember, I squared is equal to -1. That's part of the definition. Now, I'm going to take from example 1, part B. So that was the 3 minus 5i and the 3 plus 5i. And then I'm going to ask you about these two problems in a second, what you might notice about what happens when we multiply these conjugates together. So, little foil or box, whatever your favorite is. So I'm going to take, actually, you know what, I'm going to draw a little box on this just to help me organize it a little bit better. So just one of them's 3 minus 5i, one of them's 3 plus 5i. So this would give me 9. You'd get 3 times 5i is 15i. 3 times -5i is -15i. And so if you guys notice right then and there, these are opposites. So they're actually going to cancel each other out. And now the bottom corner, -5 times 5 is -25. I times I is I squared. What is this -25i squared really equal to? 20. Okay, so this box is really 25. What I have left here, I have 9 and I have 25, so we can actually add those together. So if I multiply those conjugates, I just get 34. So what do you guys notice is happening if I multiply conjugates together? Are we noticing anything? The middle term cancels out. And is there anything else you notice? Yeah, you don't. Yeah, it cancels out that middle term, so it cancels out all the imaginary parts. So I'm going to write that all imaginary parts cancel. So if you multiply conjugates together, that'll get rid of any I that you might have, which we are going to actually need to use in a couple of these problems where we're going to do the division. Okay, now if you want to look down the page a little bit to example 3, those are all complex fractions. They just involve I in some way. And to simplify these, there's really just one rule we have to follow, and that is, you are not allowed to have I in the denominator. Not allowed to have I in the denominator. It's not considered simplified. Totally fine for I to be somewhere in your numerator, not okay for I to be in the denominator. Okay, now, if you have an I in the denominator, what you're going to do, so I'm going to write this, to get rid of I, if you have it in the denominator, you are going to multiply by 1. You're going to multiply your expression by 1, and I put little quotation marks around that. I will show you how to do that in 1 second. But 1 is going to be of this format. It's going to be the conjugate of your denominator, whatever that is, over the conjugate of your denominator. And that will just actually be equal to 1. If I divide something by itself, like if I just have 5 over 5, that's equal to 1. So if I do the conjugate of whatever's in the denominator divided by the conjugate of the denominator, I'm really just multiplying by 1. Each one of these is a little bit different. So let me start with the very first one I have here, which is 2 over negative 6i. Okay, now, let's not worry about the I in the denominator just for a second. Could you simplify the fraction as it's presented right there at all? The 2 over negative 6i. Can I simplify anything there? Yes, you can reduce this just like you would reduce a normal fraction. Those are both divisible by 2. So this is the same as 1 over negative 3i. Now, I still have an issue here because I have an I in the denominator. All you have to do to get rid of I in your denominator is I'm just going to multiply by 1. But when I write 1, I'm going to write it in the format of the conjugate of the denominator. So this is negative 3i. So its conjugate would just be positive 3i. Positive 3i. Whatever I do to the bottom, got to do the same thing to the top. That way I'm multiplying by 1, and so then I'm giving an equivalent expression. I'm not changing anything. And actually, before I do that, I'm going to ask you guys, and I'm going to ask you to add this in, because these questions, I'm going to say write your answer in A plus BI form. So when we get done, I want it to be like the real part plus the imaginary part. We'll write it in that format just to practice that today, because a couple of these questions are kind of tricky to do that with, so I want to show you how. Now, if I just go ahead and do what I was writing there, do not need a common denominator to multiply, just straight across the top, straight across the bottom. So this would be 3i negative 9i squared. Now, if I chose the conjugate, that should cancel any imaginary parts in the denominator, so that's what we're trying to get rid of. So I would still have 3 on the top. What would the bottom of that be? 9. This would be positive 9. Negative 9 times negative 1. This is 9. Okay, now, you can further reduce that. So 3 over 9 is 1/3. And I know this is going to be a little weird, but this would be I over 3. Okay. Now, I'm just going to do this so you guys can see it. If I want to write it in A plus BI form, this would be the imaginary part. This would be 3/9 is the same thing as 1/3. So if I was writing this in A plus BI form, I don't have a real part. So I would start it out with 0. This is positive. And what I would do here, if I do B times I, this is I over 3. That's the same thing as 1/3 times I. So I'm just kind of pulling that fraction to the side so I is next to it, and then that is in the A plus BI format. Anybody have any questions? Tell you what, okay, let's skip this one for the moment just to save some time, but I do want to do the one at the bottom. So I can't simplify anything there. I have 7i, I have 3, and I have negative 9i. Those three numbers, or those three terms, if you will, don't have anything in common. So I cannot reduce that in any way. So my only thing here is I'm not allowed to have an I in the denominator. So I need to multiply the top and bottom here by the conjugate of the denominator. If I do that, all the imaginary parts will cancel out. So literally just need to change up whatever the sign is in that denominator. So it's a minus. So I'm going to change it to a plus. Okay, in the top part of this, this would be just a little distributive property. So I'm going to take 7i times both of those terms. So we would just have 7i times 3, 21i, 7i times 9i would be 63i squared, which, what would 63i squared really be equal to? Negative 63. Okay, now, this is just, I'm going to write NUM to abbreviate numerator. So that's just the numerator. Okay, the denominator, and if you want to draw a little box, you could totally draw a little box if you want. I sometimes like to do that with the imaginary numbers, but you don't have to if you want to just do a FOIL. So I have a 3 and a 9i and a 3 and a minus 9i. Okay, now I know immediately, because I've been teaching this longer than any of you have been alive, that these two boxes are going to cancel each other out. So when I do these problems, I don't even do that. But if you want to put it in, this would be a negative 27i. This would be a 27i, but I just don't even do that part of the problem, to be honest with you, when I'm doing this. The only two that matter if you're multiplying conjugates together are the first two and the last two, because these cancel each other out. This would be 9. Now, the bottom corner, because they're conjugates, one's always positive and one's negative. So you have positive 9 times negative 9, which would be negative 81i squared. What is this box really equal to? 81, right? Because you have negative 81 times negative 1. So that's really what's going on there. Now, all that's left is the 81 and the 9. So all in total, the denominator there would be 90. Okay, so my numerator was, I'm just going to write this so the real part comes first. Negative 63 plus 21i all over 90. Now, are all three of those numbers divisible by anything? 3. Okay, now it's got to be all three. If it's not all three, you can't do this. But all three of these are divisible by 3. So this is going to be negative 21 plus 7i over 30. Sorry, I had to think about that way too long. Okay, now I'm going to separate this and write this in that a plus bi format. So this will be negative 21 over 30 plus 7 over 30i. Now, can I reduce negative 21 over 30? Those are both divisible. So if when you separate them, if you can further reduce one of the fractions, or maybe both, it shouldn't be both of them, but if you can reduce one, you are totally allowed to do that. So this would be negative 7/10, and then, sorry, I'm really close to the bottom of the page. That 7 over 30, that doesn't reduce, so that would stay 7 over 30, and the I would be next to it. So negative 21 over 30, I just divided both terms by 3, and then 7 over 30, that does not reduce. Is anybody having a question? Okay, I do want to do one more problem with you. So this is like the worst that it could possibly get. And then the part at the bottom, I promise, is quick. Okay, so this is the worst possible situation you could be in. You have a binomial on the top, so 2 terms, binomial on the bottom, 2 terms. Nothing reduces, nothing cancels here, so I've got to multiply top and bottom by the conjugate of the denominator. So all I got to do is change this up to 8 plus 7i. Okay, now again, you do not have to do this, but sometimes I like to with the imaginary numbers. I like to use a little box just to help myself. So the top, the numerator, would be negative 1 and 5i, and then I'm going to multiply that 8 and 7i. Now, nothing is going to cancel because these are two totally different complex numbers, so I'm going to go ahead and FOIL this whole thing out, or use my box to multiply this out here. This would be minus 7i, this would be 40i. Now, down in the corner, 7 times 5 is 35. I times I results in I squared. So that bottom box is really what? This would be negative 35, because you have 35 times negative 1. Okay, now, what I have in terms of simplifying that, negative 8 and negative 35 together would be negative 43. And then 40 minus 7 would be 33i. So that's just the numerator. Okay, now the denominator. I'm going to multiply these conjugates together. That should get rid of all the i's, which is the entire goal of this whole process. And if you want to, you can, but you do not have to. I just immediately know those two boxes are going to cancel each other out. If you wanted to write it in, this would be negative 56i, this would be positive 56i, but they're going to cancel each other out. So like I said, I don't even do those two products. This would be 64. Now, negative and a positive multiplied together, because you'll have conjugates, so it'll always start out with a negative. This is negative 49i squared. So what is this little box in the corner really? This is positive 49, because you'd have negative 49 times negative 1. So the whole denominator of this fraction, we would add these together, and this is not a nice number. So this is 113. So that's my denominator. Okay, so after all that, I have negative 43 plus 33i, all that over 113. Nobody has anything in common there. You cannot reduce that. But to write that in that a plus bi format, all I'm going to do is separate the two terms into two fractions. So I'd write negative 43 over 113, and then it's plus 33i, so I'm just going to have a plus in between, be 33 over 113, and you just put the I right next to it. That would put that in that a plus bi format. Is anybody having a question? Okay, now, the rest of today is the cycle of I, or it says powers of I. So basically, and you guys will see this on the homework assignment, I literally took like practice questions from the SAT so you guys could look at these, because these kinds of questions come up on there. And so there's only 4 possible answers that you can have if you simplify any exponent for I, anything. And that's this 4, and then once you go through these repeat. And so what I have here is just I squared, I to the third, I to the fourth, and then in the table here I just show you kind of how that cycle repeats and starts over again. So there's only 4 possible answers. So let me explain these really quickly. So the first one, literally just I to the first is just I. That's you can't do anything there. So just I. So that is the first possible answer. There are 4 possible answers for any power of I. So that's the first one, just a plain I by itself. Okay, now I squared is equal to what? Negative 1. So if I get I squared, I can actually just simplify that, and that becomes a real number. That becomes negative 1. Now, the other 2 are a little bit weird, so I want to explain those a little bit more. I to the third, or I cubed, I'm going to use my properties of exponents and just rewrite this really quickly as I squared times I to the first, right? If I multiply like bases, I'd add my exponents. If I simplify this, I know I squared is equal to negative 1 times I. So they'll tell you in that third part of the cycle, this could be simplified to just be negative I. What I'm doing, I squared becomes negative 1. I still have the I left over, so this is negative I. So that would be imaginary, but it would be negative. And then the last option, I to the fourth, this is the same as I squared times I squared. 2 plus 2 would add back up to the 4, but we know I squared is equal to negative 1. Negative 1 times negative 1 will result in a real number, which is actually now positive 1. Okay, now how this works with exponents, you guys will look down the page, like this says I to the 63rd. Okay, what you want to do, if you can divide that exponent, because there's only 4 options here, if you divide that exponent by 4, okay, if the remainder is 1, if you divide by 4, if the remainder is 1, you'll have I. If the remainder is 2, when you divide the exponent by 4, that will be negative 1, or equivalent to I squared. If you have a remainder of 3, that will be equivalent to I cubed, which is negative I. And if you have, it would really be remainder of 0. So if the number that you got as your exponent, if it's divisible by 4, then that will be equal to 1. So these are the options. And of course, you don't have to write this out by longhand, but I'm going to just show you long division for this just really quickly. So if I take 63 and divide that by 4. Okay, I'm going to practice my long division here. 4 goes into 6 once. This would be 4. 2, bring down the 3. This would be 5. This would be 20. Okay, so my remainder here would be 3. So this is equivalent to I to the third. And if you look up to that little cycle there, that is equal to negative I if I simplify it. So I'm just looking for the remainder. Okay, divide by 4 because you only have 4 options. That's what's going on there. If I put that into 73, this would be 1, 4, bring this down. 4 goes into 33 8 times. This would be 32. So my remainder would be 1. So that is equivalent to just I to the first, which is just simplified to be I. Do you guys remember for your properties of exponents, if I tell you I've got I to the 10th, I to the 3rd, I to the 27th, how would you simplify that? How would you simplify the exponent? You guys remember? Add them up. Okay, so don't judge. I'm grabbing my calculator. Okay, so 10 plus 3 plus 27. We would add these up. Okay, now this gives me I to the 40th. Okay, now if my remainder is 0, this is equivalent to I to the 4th, which is just positive 1. Positive 1 there. If your remainder is 0, that's that last step I showed you in that cycle. Okay, now, this is another exponent property. If I have a power to a power, do you guys remember what to do with the exponents? Multiply. Okay, so this would be I to the 30th. What would, if I divided 30 by 4, what would my remainder be? 2, right? Okay, so if I, okay, maybe I should write that out. So 4 goes into 30, what, 7 times, then you'd have 28, and you'd have 2 left, so your remainder would be 2. So this would be equivalent to I squared, which you guys know by definition is negative 1. Now the next one's weird. You cannot add these two terms together because they are not like bases, or they're like bases, but they're not like terms because they don't have the same exponent. So I'm just going to leave this as I. Now I to the 19th would be, if I divided that by 4, what would my remainder be? So this would be equivalent to I to the 3rd, which is simplified to be negative I. So really what I have here, I plus negative I, which is 0, exactly. And then the last two, this is really just me trying to review exponent properties with you a little bit, which we will use many, many times as we go through the course of the year. Anybody know how to simplify a negative exponent? If I have I to the negative 22, how could I rewrite that? Put it over. Okay, now, I always tell people, like, move it and lose it. So you're going to move it to the opposite part of the fraction and lose that negative exponent. So this would be equivalent to 1 over I to the 22nd. Okay, if I divided 4 into 22, what would my remainder be? 2, right? So this would be equivalent to 1 over I squared. What's I squared equal to? Negative 1. So this ultimately, that whole thing just simplified would be negative 1. The very last problem, and I did this one on purpose. Okay, this confuses people. So if you have a negative exponent, which I do here, I have negative 6 times I to the negative 32nd. If you are trying to simplify that to get rid of that negative exponent, you only move what has a negative exponent. So not a negative number, a negative exponent. So that negative 6 would stay on the top. This would then become I to the 32nd on the bottom. Okay, if I divide 32 by 4, that goes in, right? 4 goes in. So this is equivalent to I to the 4th. And if you guys remember that, I to the 4th, I squared times I squared, is just equal to 1. So ultimately my answer would be negative 6 here, because it was negative 6 from the top of the problem, because I'm just dividing that by 1.